Okay, well, good morning, folks. It is good to see you. Glad you're here. Thank you again for being part of the program. We really do appreciate it. We got 2 more weeks, and then we get ourselves a big break until July. Just a couple things I want to recap to make sure that everybody's up to speed on. So here is our Google website, just in case. Here's the code in case anybody still needs to join, CIPUOMM7. I also have it up on the front board. But if you're ever absent, this is where you're going to find all of our notes. I'm going to post the video links, everything you're going to need. So if you ever have any questions about that, just let me know. So currently, we are in the week of June 2nd through June 5th. Let's see what we got planned for today. Here, of course, is our daily schedule. That was last week. Okay, so it looks like today we're going to focus all of our attention on quadratics. Going into tomorrow, we're going to look at factoring. Wednesday is going to be systems of equations. And then on Thursday, we're going to finish up the week with a little review as a Jeopardy game. Okay, so try to throw a little bit of fun into it, but I know you're probably thinking to yourself, well, it's already fun. It's math, right? Exactly. So I do want to go ahead and throw out one thing. You'll notice today at the very bottom, it says begin the quadratics homework. So one of the papers you picked up today is a quadratics homework assignment. So if you complete this, sometime tonight, you bring it in tomorrow and you turn it in. Now, we're not looking for accuracy. We're just looking for completion. If you go ahead and turn it in tomorrow after we discuss it, you're going to get your name put in a drawing for a gift card. I think we're going to like Sonic and places like that. So absolutely, I would encourage you to go ahead and do that. It's math anyway. Plus, you could also get yourself a nice drink or maybe some food, depending on where the gift cards are to. So that'll get your name in the drawing one time. After we talk about any questions on the homework assignment tomorrow at the beginning of class, after that, we're going to have a quiz over the same material, quadratics. Now, I'll double check this, but I believe if you score at least a 60 or above on the quiz, that's a second opportunity to get your name into the drawing for the gift cards we're going to have, and they should be taking care of that at the end of the week. Okay, so you got a homework assignment to take a look at. And remember, there's no grades in here. There's nothing saying that you absolutely have to do this. So if you don't want to work the homework, completely up to you. But I would encourage you to do it because, you're here in the summer, this is your time, and I want to make sure that it's well spent. But you do have opportunities to get that gift card. Are there any questions about that? Any questions about what's coming up this week? Okay. Or any questions about the Google Classroom in general? Yes.
So are we starting back up in July after that break?
Yes, I want to say it's the week of July 14th. Let me double check on that real quick. Yes, it should be the 14th to the 17th. Okay. 14th to the 17th. And then after that, we have 2 Saturdays that we're going to meet in the fall prior to the PSAT in October. One of those Saturdays is going to be English, and the other Saturday will be all mathematics. But we will let you know those dates the closer we get. Okay, good. Any other questions? Okay, well, let's go ahead and get to it. You've been waiting 3 days. You want to get back to mathematics. So we're going to start with focus activity number 3. Does anybody need a copy? I believe, or maybe I kept them over here. Where did I put those? Yes, I do. Okay. So I've got one right here. You need both of you? Okay. There you go. Here we go. Okay, got one right here. You are brand new, so we'll need one. Okay. I got 1 copy left. So if we have more than 1 person, I'll need to go make some copies real quick. Anybody else need focus activity number 3? We'll take it. All right. Here we go. Okay, so number 7. If f of x equals x squared over 9 minus 8 and f of 6a equals 4a, what is one possible value of a? So remember, once they redesigned and we're now working with this new PSAT, there are still open-ended questions, but there are no griddables. So all you got to do is put your answer. Okay, so very similar to what we did on Thursday, they're showing me exactly how they want me to create the equation. What would I do to determine f of 6a? What that? That's exactly right. I'm going to plug in 6a. So f of 6a would equal x squared over 9. So that's going to be 6a quantity squared over 9 minus 8. Remember, whatever's in parentheses, that's an element of your domain. That's what you're going to substitute. Okay, so let's simplify this. What is 6a squared? So 36a squared over 9 minus 8. So that is the left side of the equation. Now on the right side, it just says 4a. It doesn't say to do anything in that with the function. So I'm just going to say equals 4a. Okay. And now let's go ahead and simplify this a little bit. 36a squared over 9 is a 4a squared. Let's subtract that 4a over minus 8 equals 0. So we're wanting to solve this quadratic. Okay. Now I could solve it as is, but does anybody notice anything? There's a GCF. Okay, so basically here's the idea. If you're looking for where it equals 0, essentially we're trying to find the roots of this quadratic. If the values of a, b, and c all have a common factor, it is perfectly okay to go ahead and simplify those. Let's say, though, for this quadratic, I was more interested in finding the vertex, then you don't want to simplify. That's going to give you a completely different function. Okay, so in this case here, they're all divisible by 4, so I'm really solving a squared minus a minus 2 is equal to 0. And this is going to be really easy to work with. I'm going to go ahead and put a in 2, a in 1, because 2 is the only even prime number that we have. Okay, but when I multiply these, I got to get a negative 2, and then when I add them, I've got to get a negative 1. So would it be a minus 2 or a minus 1? It would have to be a minus 2. There we go. Perfect, perfect. So I was able to factor it, great. But how does that help me? What do I do to find my solutions? Okay, set them equal to 0, the 0 product property. So if a minus 2 equals 0, a equals 2, and if a plus 1 equals 0, then a equals negative 1. We're actually going to be using this several times today throughout our problems. And they both work because negative solutions are now acceptable for open-ended questions on the PSAT. Okay. So how many people had the opportunity to run home on Thursday night or even did it late last night? Got that right. Because last night you're thinking, okay, it's Sunday night, I'm going to school tomorrow, got to get prepared, right? Cool. All right. Well, let me go ahead and move this. Okay, well, let's take a look at number 8. If f of x equals x minus 3, so this time we're dealing with a linear function, and 2 times f of the square root of m equals 4. Okay, what's the value of m? Okay, so this is the same scenario we had in number 7. Now, for those of you who already know me, I'm big on audience participation. Who would like to come on up and work this for me? Okay, so many hands going up. I just need one volunteer. Okay. Remember, what does that homework get you an opportunity? Oh, you were the first one to speak. All right. Elliot, correct? No? That's okay. You look like an Elliot to me. All right, come on up. See, I can only do that so often because then when I'm genuinely asking a question, nobody talks. So we'll see. All right, so help us out, sir.
I have no idea.
Okay, so let's help him out. Where would we start? Now, we're not plugging in 4. What are we plugging in? Root m, square root of m. So forget about the 2 for a second. What would f of square root of m look like? Are you okay with what I'm asking? I'm going to take that as a no. Okay. So remember, let's do it like this. So you want f square root of m, right? So you know what function f is. Let's say, what if I asked you f of 3? What would you do? X minus 3 would become what?
3 minus 3.
There you go. See, whatever you're given in parentheses is what you're going to replace the variable with.
Okay.
So we want to replace it with square root of m. So what is f of root m? There you go. So now that's f of root m. how would I show that we're doubling that?
Same the entire thing.
The entire thing. There you go. Now you've got the left side of the equation. And what am I going to set that equal to? Perfect. And then now we just solve it. That's it. Now there's here you have a choice. You can actually either distribute or you can just divide the two out. Either way, it'll work out just fine. So what would you like to do? Square root of m minus 3 is equal to 2. So square root of m is equal to 5. Very good. So what would I do to both sides? There you go. M equals 25. There's my solution. See, you knew what to do. Got it. Questions? Okay. We got to the root of that problem, right? Who said, oh dear? Okay. Right. That's right. Okay. All right. Number 9. Okay, after production, the total profit P in dollars from selling Q basketballs is given by the function P of Q equals 10Q minus the sum of 3Q and H, where H is a constant. If 200 basketballs were sold in March for a total profit of $1,150, what is the value of H? Okay, so how many people had the opportunity to work this problem ahead of time? Okay, so let me give you a couple minutes. Okay, we'll come back and we'll see who can help me out with this. So I'll still work it, just need somebody to give me the answer. So I want to give you the opportunity to try it. So we are solving for H, our constant. "45 seconds. Seconds. And here we go. Okay, so before we go ahead and run through it, anybody think they've got the answer? Okay, what you got, sir? 250 is what we're looking at. There we go. 250. How many people got that? Nice. Nice. Now, before we go ahead and get started, can somebody just help me out real quick? What does this say? Oh, you're welcome. Thank you. You're welcome. Yeah, I got that. Yeah. I mean, you're already having so much fun with math. I mean, I really shouldn't make it, give it too much fun, but okay. All right, so Q is the number of basketballs, and we're given 200 for that total. So we're going to go ahead and start to plug this in. So 10 times 200 will give me 2,000 minus, if I triple 200, I'm looking at 600 plus H. And what do I want to set this equal to? 1,150. Okay, so 1150 is equal to, if I went ahead and, I'll just, so I don't have to rewrite the whole thing, that would be minus 600 minus h. Okay, well that's going to give me 1400, yeah. Okay, minus h, and then 1150 minus 1400 is a negative 250 equals negative h, and then of course we don't want our variable to be negative, so we can multiply or divide by a negative 1. Okay, questions? Nothing but net. All right, we're good? Okay, well, go ahead and take this, put it to the side. We're done with our focus activity. Now on to the main topic. We're going to go ahead and talk about quadratic functions, some characteristics, and then we're going to get into strategies for solving these. Now, I'm not going to go ahead and read this verbatim. I'll let you go back and take a look at it at some point. But suffice to say that every parabola, no matter what direction it opens, is going to have, going straight through the middle of it, what's called an axis of symmetry. So if I fold the two sides together, they're going to come perfectly like mirror images. Okay, in mathematics we say that they coincide. Okay, you know what you should do when it rains? Coincide, go inside. I'm on fire today. That's no cap, right? Come on, let's put some W's in that chat, fam. Yeah, okay. I kind of figured that'd work out as well. But where the axis of symmetry and the parabola intersect, that's where you're going to find your vertex. Okay, and we got some bullet points right here. So consider the standard form of a quadratic. Y is equal to ax squared plus bx plus c, where a cannot equal 0, because then it's a linear function. So the first bullet point, the y-intercept is your constant c. The equation for the axis of symmetry, what we'll often refer to as just the AOS, is the opposite of b divided by 2a. Now this expression can also help you determine the vertex, because this is also the x value of your vertex. So you'll see this in a lot of resources. The vertex is going to be labeled as the opposite of b over 2a, but then you're going to plug that value back into the function. So f of the opposite of b over 2a. Okay, so once you have the value of x, you plug it back in, you'll find the corresponding y value. Okay, so with this in mind, let's try an example. So we're given f of x equals 2x squared plus 4x minus 3. So without doing any work, what's the y-intercept? Negative 3. That is my constant. So I know that I'm going to go ahead and place a point right here at negative 3. Okay. Now, because we have a positive leading coefficient, does it open up or down? It opens up. Okay. So let's see what we got here. Let's go ahead and figure out the equation for the axis of symmetry, but we'll also go ahead and use this to find the vertex. So the opposite of b divided by 2a. Well, this is, let me use a different color here. So this is a, this is b, and this is c. All right, so what's the opposite of b? So negative 4 divided by 2 times a is 2. So it looks like my axis of symmetry is going to have an equation of x equals negative 1. Okay, but I can also use this to find the vertex, which is the most important point. So the vertex occurs when x is negative 1, but how do I find that corresponding y value again? By plugging it in. So now we want f of negative 1. So 2x squared would be 2 times a negative 1 squared plus 4x, so plus 4 times a negative 1. That looks awful. I can do better. Negative 1. And then we have minus 3. Okay, let's see. Negative 1 squared is 1 times 2, so that's a 2. Plus 4 times negative 1, and then the minus 3. So what are we looking at here? Negative 5. So my vertex occurs at negative 1, negative 5. And of course, there's other ways to find the vertex. You could complete the square and rewrite it in vertex form. You know, we'll talk about that later. So let's see. Negative 1, negative 5 is my vertex. So let's see here. Let me get a different color. So that is right here. Here's my axis of symmetry. And it only takes how many points minimum to go ahead and graph a parabola? Like a line, you need minimum 2. So for a parabola, you need minimum 3. And I've already got 2 of them. Now, we could go ahead and plug in another value of x. I mean, it'd be super easy to do, but why don't we just go ahead and take this y-intercept? Let's use the symmetry of the graph and reflect it over. See, it's 1 unit away from the AOS, so its image would have to also be 1 unit away. So we have a really good idea of what this particular quadratic is going to look like. Okay. All right, so questions. The good old days of algebra are kind of coming back to us. Fantastic, fantastic. Okay. Well, this next concept we already talked about, we kind of brought it up last week. If you're talking about a parabola and it refers to a maximum or a minimum, that is talking about the vertex. But specifically, it wants the y value of your vertex, the element in the range. And then we already know if it opens up or down, depending on that leading coefficient. If A is positive, it opens up. A is negative, it opens down. And depending on that, is going to result in a maximum or a minimum. Then, of course, we have domain and range. Now, domain and range is simply how much space your graph occupies in the coordinate plane. Okay, so I'm always asking myself these 2 questions. If I'm talking about domain, I want to know how wide it is. If I'm talking about range, I want to know how tall it is. Okay, just the amount of space. What are all the corresponding values for that graph in the plane? Okay, so with all this together, let's try another problem. So consider f of x equals negative 3x squared plus 12x plus 11. We got 3 parts. Determine if it has a max or a min. Find the value of the maximum or minimum, and then state the domain and range of the function. Okay, so we've already worked one of these, so let me give you a couple of minutes. Try this one. And then we'll come back, we'll go ahead and talk about it. Then we'll start looking at some actual strategies. We'll kind of get away from the characteristics. Excuse me. $45. $10. All right. Okay. So let's see here. Cool. Okay, correct. Okay. Maximum or minimum? It's going to have a maximum. Because my leading coefficient is negative, we know this parabola is going to be opening down. Fantastic. Okay, so since we are looking for a maximum value, okay, I've already talked to you. What'd you get? For the maximum value. And that's okay if you haven't got it. That's okay. Do you have a number or do you want to pass? Okay. Let's see, Livia. Okay, so the vertex is going to be located at 223. So the maximum value that we would want is 23. Remember, the maximum or minimum refers to the y value of your vertex. Yes. Okay, and then we want to go ahead and state the domain and range of the function. So we'll just go ahead and do this for the range. We'll just go ahead and write it as an inequality. What should I put for the domain?
Negative infinity.
Okay, so if you want to write it in interval notation, absolutely. We could say negative infinity to infinity. Okay, a lot of people probably just went ahead and said all reals. Either of those are perfectly acceptable. Okay. In fact, for the range, who can help me out with that one? Okay, Harrison, what'd you get?
Negative infinity to 23.
Negative infinity to 23. Perfect. So negative infinity to 23. Now, because we're going to include the 23, I'm going to put a bracket on that one. And if someone went ahead, like I said, did it as an inequality, y is less than or equal to 23, that is perfectly fine as well. Okay. All right. Any questions? Does anybody want me to show how I got the 2 or the 23? Any of that? Yes.
What does a bracket mean?
Oh, the bracket means that that value is included. So when you're talking about, like, let's say we have like a compound inequality, like maybe, oh, I don't know, negative 2 is less than x, which is less than or equal to 7, for example. So somebody's excited about math. Interval notation is just an alternate way of writing the same information. So I'm going to go ahead and put my two values, everything between negative 2 and 7, but because the negative 2 is strictly less than, the parentheses indicates it's not included. That little line right there, equality, means that the 7 is, so I would put a bracket on there. Okay. That has nothing to do with this problem. I just kind of made that up off the top of my head. Okay, good. Any other questions? All right. Now we're going to go ahead and start getting into strategies. So we're going to be looking at factoring, quadratic formula, and completing the square. Now, out of those three, one of them will not work 100% of the time. Which one do you think I'm referring to? Factoring. Fortunately, not every quadratic expression is factorable, whether it's a GCF or you're going to break it up into binomials, whatever. But completing the square quadratic formula 100% of the time will always find you those solutions, whether they're real, imaginary, whatever the case is. Now, for factoring, we're actually going to spend the whole class period talking about that tomorrow, so we're going to get into it in a lot more detail. For today, let's just go ahead. We'll do the good old-fashioned guess and check. Probably the first factoring strategy you were ever taught. I've got a particular method that I like. It is universal and it'll work 100% of the time. It just depends on if you like it or not, but we're going to talk about it tomorrow, so there's no sense in kind of taking time to do that today. So let's just get right into it. We're going to solve 15x squared plus x minus 2 equals 0 by factoring. Okay, so let's go ahead and break this apart. So we already know this one's factorable. So I'm going to go ahead and get a product of two binomials ready. Now, my constant is 2, so it's the only even prime number. So I'm going to go ahead and put 2. I'm going to go ahead and put the 1. Those are the only factors. But now we have to go ahead and decide, should it be a minus 2 or should it be a minus 1? What do we think? It would have to be minus 1. Because let's think about it. 2 times negative 1 would have to give me negative 2. But then 2 plus negative 1, it would have to give you your linear coefficient. Okay. And of course, this is why they refer to it as the guess and check. For 15x squared, we do have a couple of combinations here. We need to either go ahead and use x and 15x, or we need 3x times 5x. So we've got to decide which pair and how to put it in is going to work with what we have. So what do you think? 1 and 15 or 3 and 5? 3 and 5? Okay, so let's focus on 3 and 5. So what should go here? You want me to put the 3 or the 5 there? You want me to put the 5x? So let's put 5x there. We know that's a plus. Let's put the 3x here. Okay, now this is why they call it guess and check, because after you guessed what it is, you want to check and make sure you're correct. So let's see. Well, 5x times 3x, there's your 15x squared. We already know that 2 and negative 1 will give me the negative 2. It's really the outside and the inside products. So 5x times negative 1 is a negative 5x. Now I'm going to go inside. 2 and 3x will give me 6x. And that does give me 1x. So it is good to go. We now have exactly what we need. Okay, I'm going to go ahead and get rid of all this right here. So that's great. I was able to factor it. But now, how does that help me get my solutions? Remember, what do I do with these groups?
You equate them to 0.
Equate them to 0. So if 5x plus 2 is equal to 0, if I subtract the 2 and divide by 5, well, my first solution is a negative 2/5. Okay, if 3x minus 1 is equal to 0, add the 1, divide by 3, what's my second solution? 1/3. And remember, what are you going to have with you every problem on the math modules now? You're going to have a calculator, okay? So you could double check your work if you had time. I've got Desmos pulled up. Would anybody like me to plug this in and confirm that we got the correct answers? You want me to? Sure, let's do it. So we have 15x squared. Get my mouse here. Okay, so 15x. Oh, actually, let me close that. X squared, and then what was it? Plus x minus 2. So plus x minus 2. Okay, so let's hover over here. So we got a negative 2/5. That's a negative 0.4. And then we got a 1/3. That's a 0.3 repeating. Okay, so we got exactly what we were looking for. Good, 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 good. Okay, now let me ask you a quick question before we even go ahead and get going. Let's say I'd solved this exact same problem by completing the square or even quadratic formula. What would have been the result? You're going to get the exact same answers. So it's never going to say on a PSAT problem that you have to choose a specific strategy. It's whatever you feel most comfortable with. So I would decide, pretty early on, okay, which one you want to use most, and then kind of just, make sure you feel as comfortable with that as possible. Let's try this again. There we go. I got to calibrate this screen. Okay, so we got factoring. Okay, and we're going to spend more time on factoring tomorrow, so we're going to go ahead and move on. So now I want to complete the square. Okay, so there's actually only one tiny part of the entire process that actually is referred to as completing the square. So we've got our values, so A is 2, B is negative 13 as of right now, and then C is equal to 15, this right here. Taking the linear coefficient, dividing it by 2, and squaring it, that is what we actually refer to as completing the square. Okay. Now, in order to complete the square, you don't want everything on one side like factoring or the quadratic formula. You don't want it set equal to 0. You want to set it equal to your constant. So I'm going to go ahead and first rewrite this equation. So 2x squared minus 13x. Okay, I'm going to leave a little bit of room here, equals negative 15. Okay, so this is how you're going to start to complete the square. Okay, if it was October, we could complete the scare. October, Halloween. If it were October, we could complete the scare. I like how you had to think about that for a second before you gave me your verdict. Okay, well, let me ask you this question. There is one condition that has to be in place for you to complete the square. And right now, I can't do it. I can't just take half of negative 13 and square it. That's standing in my way. They do. They really love math. It's not the C. It's that leading coefficient. In order to complete the square, the value of A must be what? Just 1x squared. It's got to be 1. So we got a couple of different ways we could approach this. Whatever your constant is, you could either divide through by that constant, or I could go ahead and just keep it on one side, pretend that that constant is a greatest common factor. So what would you folks like me to do? Because either way is going to work out. Would you like me to divide through or factor it out? Factor it out. Okay. So let's factor it out. So if I pull out this 2, that's going to leave me the 1x squared that I need. But it's now going to be minus what? Okay, well, I'll keep it as a fraction. Everybody loves fractions. 13 halves x. Plus, leave a little bit of room here, equals negative 15. Is everybody okay why it became negative 13 halves? Because if I redistribute the 2, it's got to have an equivalent statement. Okay. So this right here, this is now what I'm going to complete the square with. That's what I have to take half of and square. Okay, so let's see what we got here. I'll do this in red. So a negative 13 halves, we're going to divide it by 2, and then I'm going to square what we get. Let's see here. What's a negative 13 halves over 2? That's a negative 13 fourths. Okay, now we're going to go ahead and square that. Now, the nice thing about this, whether your value of b is positive or negative, the square will always, always, always end up with a positive result every single time. So you really don't even have to worry about the negative if you don't want to. So what's a 13 fourths squared? 169 sixteenths. Okay, so this is what's going to fill in the blank right here. Is everybody okay so far? Is this kind of starting to come back to folks? Okay, so I'm going to go ahead and put 169 sixteenths right here. Okay, now you remember that rule, whatever you do to one side, you got to do to the other. So if I'm adding 169 sixteenths over here, well, then I'm going to go ahead and add 169 eighths over here. Wait, what? Why did I do that? There you go. You remember I brought up that rule for a reason. Both sides have to be equal to each other. Okay, so it's not that we're adding 169 sixteenths, we're adding 2 times that because we decided to factor that out. So it's very easy to forget. You don't want to do that. Okay, so let's see here. This is now what we refer to as a perfect square trinomial. That means if I were to go ahead and factor it, the 2 group factors will be identical to each other, and that's what we want because we want a squared group. Okay, so I'm going to go ahead, put the 2 here. Let me go ahead and get that squared group ready. What's it going to be in the middle, plus or minus? It's going to be a minus. It's always the same sign as your linear term, so put a minus right there. You make that a little more horizontal. Now, all we have to do to fill this in is take a look at your first term and your constant here. We want to take the square root of those. So what's the square root of x squared? That's x. Square root of 169 sixteenths? That's 13 over 4. And then now over here, we just have to go ahead and combine those values. Everybody okay so far? Okay. So let's see here. I need a negative 15 over 1 plus a 169 eighths. So the common denominator is going to be 8. So first up, I need, what's a 8 times a negative 15? Negative 120 plus 169 eighths. So how many eighths am I looking at? 49. So we're looking at 49 eighths. Okay, everybody's okay? Okay. All right. So now we're just solving the rest for x. First, I go ahead and get rid of the 2. So you could divide through by 2, or you could just go ahead and multiply through by a half. But I'm going to get that x, ooh, let me go back to blue. I'm going to get that x minus 13 fourths squared is equal to 49 sixteenths. So how am I going to get x from under the square? Somebody is really enjoying their math today. Say it. Oh yeah, but it's math. Yeah. So what am I doing here? Square root. So this is going to be x minus 13 fourths, because a square and a square root, they are inverses, they'll cancel. What's the square root of 49 sixteenths? 7 fourths. But I am forgetting something. Plus or minus. Because we're using an even root to solve an equation, we're going to put plus minus in front of that. Okay. Any questions so far? Now, would everybody agree in order to solve for x, I'm going to have to add 13 fourths over? Okay, so I'm just going to go ahead and break it apart now. So one of the answers will be 13 fourths plus 7 fourths, while the other one's going to be 13 fourths minus 7/4. Okay, see how I just separated it based on the plus minus? 13 plus 7 would give me 20/4, so my first answer is 5. 13 minus 7 would give me 6/4, so my second solution would be 3/2. Okay. Now, at least in my experience, okay, out of all the strategies that I always discuss for a quadratic equation, completing the square typically kind of falls at the bottom of that list. Okay, it's not difficult. It is a little more time consuming than the other two methods. I mean, if it's not factorable, I'm probably definitely going to go with quadratic formula. But is there anybody in here who's like, no, I'm going to complete the square every chance I get? Okay, all right. So there we go. Questions. Any part of this where I lost anybody? Okay. Final strategy, quadratic formula. Okay, so here is our quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And I'm always curious, how many of your teachers taught you to remember this through song? You can kind of mimic it with Pop Goes the Weasel or something like that. The opposite of b plus or minus the square root. So some people know what I'm talking about. Some people don't. That's okay. All right. Well, this radicand right here, b squared minus 4ac, that's what we refer to as the discriminant. Okay. When I always teach this, I have my students determine the value of the discriminant first because that's a predictor. That's going to tell you how many real solutions you're going to end up with. So I'm going to go ahead and write those down very quickly. So if you evaluate b squared minus 4ac and you end up with a positive number, something greater than 0, you're going to have 2 real solutions. Okay. What if the discriminant, b squared minus 4ac, equaled 0? Do you have any real solutions?
Yes.
How many?
One.
Just one. One real solution. And the only other possibility, b squared minus 4ac, if that is less than 0, how many real solutions would you have? 0. So no real solutions. This is when it's going to go imaginary. So you're going to be using the imaginary unit I. Okay. All right. Well, let's go ahead and get to it. We want to solve 4x squared plus 7x minus 2 using the quadratic formula. So just like factoring, I want to set it equal to 0, everything on one side. So in this case, I see that a is 4, b is 7, and c is a negative 2. All right, so let's find that discriminant first. So b squared minus 4ac. So we got a 7 squared minus 4 times a is 4 times c, negative 2. Okay, so that's going to give me a 49. Well, the two negatives are going to give me a positive. 4 times 4 times 2, 32. So my discriminant is 81. So it's positive, guarantees I'm going to get 2 real solutions. Okay. All right, well, let's plug into the formula. X equals opposite of b. What would that be? Negative 7 plus or minus. We already found the discriminant, so this is the square root of 81. And we're going to divide this by 2a, so 2 times 4 gives me 8. And this is all you have to simplify. I mean, if you're not going to factor, quadratic formula is very, very quick. Okay. The only thing that could possibly take a little longer is if maybe you don't get a perfect root, you have to reduce it. Okay. This one's really nice to us, though. Square root of 81. Okay, 9. So I'm going to get negative 7 plus 9 over 8. Or I'm going to get a negative 7 minus 9 over 8. So in this case here, let's see, 2 8s. So my first solution would be 1/4. And what's a negative 7 minus 9? Negative 16 over 8. So my second solution or root would be -2. And there you go. Those are the strategies. Again, this very same problem, what would have happened if I tried to factor it or complete the square? You're going to end up with the same result. Especially with completing the square, it might take a little longer, but you're still going to get the same values if all your computations are correct. Okay, so we have 1052. This is perfect. What we're going to go ahead and do now, how can you suffer doing math? That's crazy. That's just crazy. Okay, so go ahead and take a look. The other packet, this is the Passport to Advanced Mathematics, but it just says Quadratics at the top of it. Now, this contains a lot more than Quadratics. So if you have, a little bit of time, I would encourage you, definitely take a look at this. There's some rational functions in here, exponential, all kinds of stuff. But since today is all about quadratics, we are only looking at numbers 4, 5, 6, and 7. Okay, so 4, 5, 6, and 7. Okay, so let's go ahead and put what we just talked about into practice. I'm going to give you 12 minutes. Let's see if we can find the solutions to these. Now, for this first one right here, this word problem, my hint is to use the DIRT formula. The distance is equal to speed times time. That is very useful in setting that one up. Okay. All right, got my timer. That is good. Yeah, that will help you, yes. And just think, this is a scenario where a guy's driving, has to hit the brake because he sees a stoplight. So you could do this on the way home. Math is everywhere. That's our friend. Okay. So remember, we are working 4, 5, 6, and 7. So I'll be walking around. If you want me to check an answer for you, I can definitely do that. If you get stuck, I can try and point you in the right direction. Now, let me give you one more strategy, and then I'll stop talking so I don't, break your concentration. But if you're one of those individuals who really doesn't like these big word problems like this, one really good strategy is to read the last sentence first. Because what is that last sentence going to be? Yeah, what you need to do is going to be the question. So a lot of times, if you go ahead and read that first, you already know what you're looking for. Then as you read through the problems, you can sort through, okay, I need that item, but I don't need this other one. Okay, right. Anybody stuck? Anybody need help? I'll get you equals. So this is the first of the steps. This is the second. That's 65. Total size. Yes, accept X over, oh, that's 20.
It's really like the super reaction.
Yeah. I will tell you, it is a fractional case. I don't think it's 40, I think it's a positive one-third. What do I get for that? Oh, is that a mixed number? I thought those were two different answers. Oh, yes, that's correct. Okay, that's fine. There was enough space between them. I thought they were different values. You guys doing okay? There you go. Yeah. There's others that I'll drink in a pinch, but I really like this zero. Is that the pipeline punch? Because I know there's a couple of pink ones, but the pipeline punch, that's the one my wife loves.
It's just good. I used to be a white all the time. It's a ruby red.
Yeah. I like the orange one. The original, like if there's nothing else, I'll drink it, but it's definitely my first choice.
Like the green one.
Not big on the tea ones. Yeah. 5.5 minutes, so you still got plenty of time. 2 minutes. And then we'll go ahead and start talking about it.
No. This is the minus. This is minus. And then it becomes a plus. So it's 15. So I just don't know how to do basic. I got 7. Obviously 15. Look at this. This is 7. You got 7.
30 seconds.
They kind of thought we were trolling, but we just got basic addition. Really dumb.
Nope.
For number 7, it's just like combining like
Number 7. Yeah, so once you get those 2 solutions, you're just going to add them. Yeah, once you get the 2 solutions, you're just going to add them up. All right, so that is 12 minutes. Okay, even if you didn't finish all 4 of them, that's perfectly fine. Let's go ahead and talk about what we got here. Number 4, a car is traveling at X feet per second. The driver sees a red light ahead, and after 1.5 seconds reaction time, the driver applies the brake. After the brake is applied, the car takes X over 24 seconds to stop, during which time the average speed of the car is X over 2 feet per second. If the car travels 165 feet from the time the driver saw the red light to the time it comes to a complete stop, which of the following equations can be used to find the value of X? Okay, so this one, I just kind of broke it down into 3 parts. Remember, everything was going to be based on this formula. The distance equals your speed times time. So the first part here, the car's traveling at X feet per second, okay, and the driver sees the red light ahead, and after a 1.5 second reaction time. So we've got our speed, okay, we've got our time, so we're going to go ahead and take a product of that. X feet per second times 1.5 seconds, okay, where the seconds are going to cancel, so that gives me 1.5x feet. Okay, so that's how far the car traveled from the time he sees the light to the time he first hits the brake. Okay, then the second part here, once the brake is applied, it takes X over 24 seconds to stop, so there's my time, and during which the car is still traveling at an average speed of X over 2 feet per second, so there is my speed again. So this time it's going to be X over 2 feet per second times the X over 24 seconds. Okay, so once again, the seconds are going to cancel. So we've got our second distance, X squared over 48 feet. Okay, everybody's okay so far? Okay. Then it goes on to tell me that the total distance for everything is 165 feet. So I'm going to take my 2 distances, I'm going to add them up. So 1.5x plus x squared over 48 is equal to 165. Now, looking at all my answers, they're all set equal to 0. So let's go ahead and rearrange this. X squared over 48 plus, and I'm going to go ahead and change this decimal to an improper fraction. So that would be 3/2 x minus 165 is equal to 0. Okay, so I got my base equations. Everybody okay with that? Now comes the easy part. I just have to go ahead and get rid of those fractions. Okay, what do you suggest I multiply by? 48. Okay, so if I go ahead and multiply through by 48, that is going to give me x squared plus, okay, half of 48 is 24 times 3, which will give me 72. Okay, so we know it can't be A or B. And what is the 48 times 165? 7,920. That is a horrible 20. I can write that better. 7,920 is equal to 0. So D should have been your answer. How many people got that right? Okay. So if you're not raising your hand, is there anything I could do? Anything I can do to help out? Yeah. Okay. Did anybody happen to solve it a different way? Okay. Well, moving on. Number 5. What are the solutions to x squared minus 3 equals x? Okay, so this one here doesn't give you a strategy. I would probably use quadratic formula or completing the square. But I'm sure at this point you're tired of listening to me. You want to listen to one of your peers. Who wants to? You want to come up again? Are you sure? Because you already came up. Let's spread it around a little bit, because there might be someone out there who's like, I want to have fun too. Sir, you want to do it? Okay, Colton, right? Right. Okay. Okay. So Colton, will you complete the square or use the quadratic formula?
Quadratic.
Quadratic formula. Perfect. So for that, we need everything on the same side of the equation. Okay. So we are working with x squared minus x minus 3 is equal to 0. Perfect. Okay. So A is 1, B is -1, and C is -3. Go. Okay. Perfect, perfect. And now this is crucial because it could potentially give me the other value. When we're plugging in a negative number, always a good practice to put it in what? Parentheses, yes. Because that'll guarantee that that square will give us the positive we need. So -4 times 1 times -3, 1 plus 12. There we go. So we know at the very least it cannot be A or C. So the opposite of B, plus or minus the square root of, we found that to be 13. Very good. All divided by 2 times A, so that is 2. Perfect. And our answer is what? D. Good job. Fantastic job. There we go. How many folks got that right? Nice. Did we want to solve it by completing the square? No. That was a quick no. Are we sure about that? I mean, because it builds character. Okay. All right. So we're done with that one. That was quick. All right. Well, let me go ahead and erase this, if it will let me erase it. Good job. Ha. Okay, example 6. So if x is greater than 0 and 2x squared plus 3x minus 2 equals 0, what is the value of x? Okay, Harrison, you want to do this one?
I was going to just answer.
Oh, okay.
X equals 4, x equals -1.
Ooh, not quite. A little off on that one. Okay.
Is it x equals -2?
That's one of the answers, but that's not the one we're looking for. Because it does say x has to be what? Greater than 0. So the answer is correct. We just want the other one. 1/2. Yes. Would somebody like to show me how we get that? Let's give it to a different person. You want to come up? All right, come on up. Remind me your name again? Colin. Okay, Colin. So Colin, how are you going to do it? This one is factorable.
Quadratic. I could do. I'll just do quadratic.
Quadratic formula. Fantastic. There you go. Okay, so the opposite of B, plus or minus.
There we go.
Okay, then we have B squared, so 9 minus 4 times A times C. Okay. Okay, so negative 3 plus or minus root 25.
And since it has to be greater than 0, then it could just be plus.
Okay.
Negative 3 plus 5 is 2.
There we go, 2A. So 2/4, you're looking at 1/2. That's it. So the two solutions would have been a negative 2 and a positive 1/2, but we get rid of the negative 2 because it did specifically want the positive. Okay, questions? All right. Now, did you folks want me to go ahead and take care of the last one, or did someone want to come on up? You got to raise your hand on this one. All right. Well, let's see here. Well, if you have an equation where both sides are squared like this, obviously to get rid of the square, you do what? You go ahead and take the square root. So if I have something like a squared equals b squared, okay, if you go ahead and apply the square root, one equation is going to be that a equals b, okay? But you also have to keep in mind that when you're talking about an even root, there are two possible roots to work with. So the other equation would be that a equals the opposite of b, and that'll get you all the solutions that you're looking for. So if I go ahead and just take the square root, well, the first one's going to be 2x minus 1 is equal to x plus 2, and we'll go ahead and solve that in just a second. Now let's go ahead and look at this one right here. So what should 2x minus 1 equal? Negative x minus 2. I'm just taking the exact opposite of that binomial. Okay. All right. Well, let's see what we got here. If I subtract the x over, that's going to give me x. Let's go ahead and add the 1. So my first solution is x equals 3. And then over here, if I add the x, I'm going to get 3x is equal to a negative 1. So x equals a negative 1/3. But this, like a lot of questions you're going to find on the PSAT, what does it want me to do now? There you go. It's going to want you to perform some kind of operation with one or both of these. So this one wants the sum. So what is a 3 plus a negative 1/3? Okay, Harrison, what you got?
2.6.
Okay, so 2.6 repeating, so you could say 2 2/3. I like to go ahead and put it as an improper fraction. That's a 3 right there. But yeah, that's fine. That's perfectly fine. There you go. All right, 8/3. How many people got that one correct? Okay. Okay. Is there anything I can do to help out? Time. It is time. So that's one of the considerations that you always want to keep in mind. Remember last week, I kept saying that you want to work at an uncomfortable pace. Trust yourself. It's when you start second guessing yourself, and going back and, doing that you're going to run out of time and you're going to start changing your answers, all that good stuff. Okay, trust yourself. Okay. All right. Well, it looks like we have 11:18, so I guess we can get out a little early today, unless there's any other questions in the packet that you were looking at and you're like, hey, I'd like to do those. Now, remember what's also due tomorrow. The homework, you could go ahead and take a little bit of time right now. You still got yourself a good 11, 12 minutes. You can go ahead and probably knock out a big chunk of that. That way you don't have to do it at home. And also, I'm here if you run into any questions. Okay. But we are done for today, so if you would like to stay, you are welcome. If you want to take off, you are welcome to do so as well. Thank you, folks, for being here.
I'm the one I guess the intro. I think it was 8:30.
8:30 and 11:30 to noon. Yes.